Dear students, in this video we will solve some numerical problems, and in this video we will solve only the problems which are related with the Fresnel Biprism experiment. So this is first problem, and problem is a biprism is placed 10 centimeter in front of a narrow slit. Suppose this is a biprism and these are the narrow slits, and this is 10 centimeter. This is 10 centimeter and illuminated by a light source of wavelength 5890, means lambda is 5890 angstrom. The separation between the coherent sources is found to be 0.5 millimeter. Small d is 0.5 millimeter. Find the fringe width. It means we have to determine W, fringe width, observed in an eyepiece placed at a distance of 70 centimeter. Suppose there is an eyepiece, or we can say screen. Suppose we can consider screen or eyepiece, and this is 70 centimeter. And we know that the separation between slit and screen, or source and screen, that is represented by capital D, and we can see that capital D is 10 plus 70, 70 plus 10, 80 centimeter. And we have to determine the fringe width. It should be capital D lambda upon small d. Capital D means 80 centimeter. We can convert it into meter. Lambda is 5890 angstrom. 5890 angstrom means we can convert it into meter by multiplying of 10 to the power minus 10. And small d is 0.5 millimeter, again by multiplying of 10 to the power minus 3. We can also convert it into meter, and it becomes 80 into 5890 upon 0.5 into 10 to the power minus 2, 10 to the power minus 10, 10 to the power minus 12, minus 3, 10 to the power minus 9. This is in meter, and after solving it, it becomes 9424 into 10 to the power minus 7 meter. This is fringe width. This is first problem related to the Fresnel Biprism experiment, and now we will solve second problem. And second problem is, in Biprism experiment, the distance between source and screen is 200 centimeter, and we know that separation between source and screen is represented by capital D. This is 200 centimeter given. Two images of slits are 0.45 and 0.29 centimeter respectively. When a convex lens is introduced between source and screen, this sentence represents that this numerical problem depends upon the displacement method. We have to determine the value of small d by the help of displacement method, and we know that in displacement method, small d is equal to under root d1 and d2. d1, d2 represents the length of images when we introduce a convex lens in between the source and screen. So this sentence represents that this numerical problem depends upon the displacement method, and we have to use this formula, small d is equal to under root d1, d2. We know that w is equal to capital D lambda upon small d, and we have to determine lambda in this numerical. So lambda equal to capital W small d upon capital D, and we can say small d is under root d1 d2 upon capital D. We should put the value of W, d1, d2 and capital D. W means fringe width, and this is if fringe width is 0.326 millimeter. 0.326 millimeter, we can convert it into meter by multiplying out to 10 to the power minus 3 under root d1. D1 is, this is D1, 0.45 centimeter means we can convert it into meter. D2 is 0.29, we can convert it into again 10 to the power minus 2 upon capital D. Capital D is 200 centimeter, we can convert it into again in meter, and this it becomes 0.326 into 10 to the power minus 3, and this is 10 to the power minus 2, it becomes 10 to the power minus 1 upon 200. 10 to the power minus 2 into 10 to the power minus 2, 10 to the power minus 4 under root, it becomes 10 to the power minus 2 under root 0.45, 0.29, and after solving it, it becomes 5.87 into 10 to the power minus 7 meter. This is wavelength of the light which is used in this numerical. So this is second type of numerical, depends upon the Freshnel Biprism experiment. After solving two problems, I will give you three problems as an assignment, and you have to solve these three problems. And first problem, as for assignment, this is in Biprism experiment, the eyepiece was placed at a distance of 140 centimeter. It should be capital D from the light source. The distance between the virtual sources 0.82, it should be small d. Find the wavelength of light if eyepiece is moved 1.723 centimeter for 18 fringes. It means the separation of 18 fringes is 1.723 centimeter. It means you have to determine the separation of two fringes, and by the help of this data we can determine the fringe width, and we have to determine wavelength in this problem. This is one. And second, a biprism experiment is set with light lambda equal to 5896 angstrom. This is wavelength of light, and in the field of view of eyepiece we get 51 fringes. How many fringes shall we get if we replace the source by mercury lamp? It means we replace the mercury lamp in place of this lamp, and we have used number one, green filter. It means this is the wavelength of green light. And second, violet filter. It means it is the wavelength of violet light. So in this problem we have to determine how many fringes shall we get if we replace number one this light and number two this light. This is second problem. Third problem, in Freshnel's Biprism experiment, the reading of optical bench, the position of the eyepiece and two positions of the lens. In displacement method we have two positions of lens, one lens, and these two positions, reading of these two positions is 99, 57 and 31 centimeter. It should be, these should be centimeter. These are the positions of eyepiece, and these two data represent the two positions of the lens. The distances between two images for the two positions of lens were 0.25 and 1.2 millimeter. These represents D1 and D2 in displacement method, as we know. The width of 20 fringes was 15.372 millimeter. By the help of this data we can determine fringe width. Calculate number one, the distance between focal plane of eyepiece and plane of interfering sources, number one, and number two, wavelength of light used, means lambda. So these three numericals we have to solve. Do it honestly in the form of assignment. Okay, thank you. And in next video, similarly, I will solve some problems of Newton's ring experiment, and I will give you some problems in the form of assignment. Thank you.